All right, you guys, we are going to go ahead and dive in and start general chemistry. So starting with chapter 1, the first thing that they talk about here is matter. I know that you guys have studied this before, so I'm just going to kind of hit the highlights on here. But you guys kind of know, and I know that you've learned in an earlier science class, that matter takes up space, it has mass, and it has inertia. We have a periodic table of elements that are made up of about 100. I mean, there's more than that, but it just depends on how many have been studied and how many are new ones. Those elements go together to make compounds. So, for example, I could have a compound of water. Water consists of 2 hydrogen atoms and 1 oxygen atom. The things that you're going to kind of do this year is kind of understand, like, I can pass electric current through this water molecule. So here's the water molecule here. And I can break those bonds between those, and I can rearrange the atoms. Well, then I've got just oxygen that we breathe, which is O2, and I also have some hydrogen, H2, that's kind of a flammable gas. So I can break that apart, and I can rearrange those atoms by electric current. But what you have to understand is reactions can be reversible. So I can actually go back the other way. I can take that water molecule, or I can take the oxygen and the hydrogen, and I can make water out of it. So that's just kind of understanding big picture of the things that you're going to look at this year. Obviously, we're going to go in a lot more depth. This is just the overview. But to kind of understand what class you're in, this is chemistry. Chemistry is the study of matter and energy. And really what we're looking at is the changes that go on. So we're going to be looking at a lot of different changes, whether they're chemical reactions, whether we're looking at the energy involved in that type of chemical reaction. So there's a lot of area in here. Why study chemistry? You become a better problem solver in anything. So it just makes you kind of understand, like some of you guys sit in a math class and you're just solving problems, where for me, I mean, I like math, I love math, but when I look at this, it's kind of a way to see how that math applies to something. Chemistry is a lot of math, but it kind of makes you become a better problem solver. And maybe it might make math a little bit easier, but math might make chemistry a little bit easier. They kind of go hand in hand here. Safety is one thing. If the Romans had actually understood, and I think that's supposed to be capital, Romans, like the Roman people, understood lead poisoning, their civilization would not have fallen. So they used lead for a lot of stuff back then, not knowing that lead can be poisonous. So another thing is to better understand all areas of science. I can honestly say my degree is in biology, but biology and chemistry go hand in hand. I had to know a lot about chemistry to actually be able to understand the biology. So some of you guys I know are juniors, and you're in maybe an AP biology class or an upper level biology or upper level science class along with chemistry. They're going to go hand in hand, and actually, you're going to see that some of the things tie together with what you're learning in one class, and they kind of tie over, and you'll see how they kind of connect. And it's kind of interesting. You kind of reach that point where things are going to kind of come together and make more sense. So the scientific method, and we're going to look at scientific notation today, but the scientific method, I'm not going to sit here and have you list the steps of it. I want you to understand how this works. So if you think about it, I mean, this is fresh on our minds, and I don't know how long this video is going to be out here, but we're dealing with COVID-19 right now, and we have a lot of scientists that are working to try to figure out, is there a vaccine? Can we have a vaccine? The scientific method is a huge part of how this happens, because people are making observations. What's working? They form a hypothesis, could this vaccine work? Could this work to do this? And then they perform experiments. The problem is their first experiment is probably not going to work. Their 55th experiment is probably not going to work, but they're going to continue to try until they figure out what's going to work. So the key here is repetition of experiments. You have to continue to figure out, what can I change? And really what you've probably learned at this point is you've got to find a way to just change one variable at a time. We really want to see, what is that change going to do? We can't change a bunch of things at once. So repetition is key. Repetition of experiments is very key. Make sure that is done. So that's just kind of an overview. We're going to move to the next page. So we're looking at, what happens after the scientific method? Well, you've got a theory. These are just hypotheses that are assembled into an attempt to explain why the whatever happened. And then we've got like a model. You know, we use models to explain natural phenomenon. So when new evidence is found, the model can change. So an example of this is this guy named Robert Boyle was an experimenter. He loved to experiment with air. So he created the first vacuum pump, which he just looked at a coin and a feather, how they fell at a different rate in a vacuum. Well, he actually discovered what's going to be called Boyle's law. You might have learned that in physical science. That's pressure times volume equals pressure times volume. So something changes. If you change pressure, that's going to change the volume. So he defined elements as anything that cannot be broken down into simpler substances. Well, then you kind of move on and you're talking about scientific laws. This is a summary of some kind of observed behavior. So a theory is just an explanation of that behavior. So kind of understanding the difference between a theory and a law is kind of important. So this statement right here is kind of, if you want to highlight stuff as you're going along, a law actually summarizes what happens, but a theory is an attempt to explain why. So the law is just this straightforward, this is what it is. Like down below when I'm talking about the law of conservation of mass. The mass of reactants is equal to the mass of the products. That's not explaining any why there. That's just telling you straightforward, summarizing, that's what this law is. We're going to look at that one, and that's dealing with chemical reactions. And then we're looking at law of conservation of energy. This is called first law of thermodynamics. So energy cannot be created nor destroyed. It can only change forms. And we're going to look at that. We're going to study thermochemistry this year and kind of look through that. So the problem with what we have is scientists and humans are subjected to all these different things. So we can misinterpret data. We have emotional attachments to theories. If you're working on a project, you might be very adamant to what you're trying to describe here. We get a loss of objectivity. We have politics involved. We have people's egos. We have people who want to make money. We call it greedy when we talk about pharmacies. Big pharmacy, you know, they want to make a lot of money. So they do have profit motives there. Different fads that go through, wars, coming up with nuclear weapons. So there's a lot involved when you're talking about the science field. There's a lot of things that can go wrong. We also have religious beliefs. So a couple of different things that have happened, like Galileo, he was actually forced to recant what his observations because of his strong religious resistance. And then I don't know how to say this name very well, but Lavo, I'm not even going to try to say it. He is the father of modern chemistry. He was actually beheaded because of a political affiliation. So, and then the need for better explosives we use for wars, it led us to discover fertilizers that can utilize nitrogen and can be used in nuclear devices. So there's been so many developments along the way. So that was just kind of an overview of chemistry and kind of what you're getting yourself into. It'll be fun. It is a lot of math, and we're actually going to start with that math right now. So we're going to dive right into scientific notation. So in science, we use a lot of quantitative data. So we're looking at things that have a number and a unit. The problem is we're looking at things that have a very large or very small number. So instead of writing those very large and very small numbers, we kind of came up with a system. It's called scientific notation. So it's a process where you have to move the decimal. I'm going to give you the steps, and then we're going to actually kind of work some practice problems on the next page. So we have to move the decimal to where we have a number between 1 and 10. The number of the decimal places, you got to count them. How many places am I moving them? And that's going to be your power of 10, or what I call your exponent, for your final answer. And you need to keep track. Am I moving to the left or am I moving to the right? If I'm moving to the left, to put it in scientific notation, my exponent's going to be positive. If I'm moving it to the right, my exponent is going to be negative. All right, so first up, we're going to put these numbers into scientific notation. So if I am working down here, and I'm going to see if I can actually put my hand on my stylus, I'm going to start right here. So my stylus is kind of not good. I'm hoping to purchase a new one. But I need to move this decimal to where I have a number between 1 and 10 instead of writing this big number. So if I put it right between the 3 and the 5, that's going to be a number between 1 and 10. So then, again, if the decimal's not there, it's at the end where I put it. It's not a very good decimal. It kind of looks like a comma, but it is a decimal. So I'm going to move that, and I'm going to count it. So I'm going 1, 2, 3, 4, 5, 6, 7, 8. I have moved it, did I count? I think 8 places to the left. Was it 8? I got to recount. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this would be 3.56 times 10 to the 8th. And that is how I write that number. Okay, the next one, the decimal is there on this one. I just need to move it to where I have a number between 1 and 10. So again, if I move it between that 4 and the 5, that's going to be a number between 1 and 10. If I try to put it between the 5 and the 9, then I've got a number that's 45.9. That's not between 1 and 10. So I'm going to move this and say 1, 2, 3, 4. And this time I moved it to the right. So this is going to be 4.59 times 10 to the negative 4. I think I moved it. I, for some reason, lose count of what I did. All right, then you're going to be asked to, it's going to be worded a couple of different ways, but it may say put the numbers like I have here, put them in long form. You may also see them say put it in standard form. It means the same thing. So this means I need to take it out of scientific notation. That means I need to do the opposite of what I did up in exercise 1. So I have a number that has a positive exponent. So think about this. That meant I moved it to the left to put it in. So to take it out, I've got to move it to the right. So I'm going to say this is 5.8. I'm going to move this 1, 2, 3, 4. And I'm going to add those zeros. And that number would be 50,000. Why is it erasing? 800. So 50,800 is my number on that. All right, then the next one. This one's a negative 8. This is a negative exponent. That means I need to look at this and say, okay, well, that means when I put this into scientific notation, I was moving it to the right. So I need to move it to the left to take it out. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, and I'm running out of space. There's my decimal, so that's going to be, and I completely messed up, so I'm going to erase that. I ran out of room. So let's totally redo that one. Sorry, guys. All right, so I'm going to write over here this time. So 6.44. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. So that's where the decimal is going to be. And I'm going to have this as 0, 0, 0, 0, 0, 0, 0. And that's why we write numbers in scientific notation, because we don't want to write a bunch of zeros. So that would be my new number. It would be point, and I would have 1, 2, 3, 4, 5, 6, 7 zeros. And then the 644. And you can put a 0 in front. It doesn't matter as long as you have the decimal in the right spot, which, again, that's a decimal. My stylus is terrible. So that's your answer for that. So that's how you put numbers in scientific notation, and that's how you take numbers out of scientific notation. Now what we're going to look at is when I have numbers that are already in scientific notation, how do I do these calculations? So there's a couple of rules, and the rules aren't really going to make sense until we actually start working them. But when you multiply, you are going to add the exponents. When you are dividing numbers, you are going to have to subtract the exponents. And when you are adding and subtracting, the exponents, so adding and subtracting, the exponents have to be the same before you start. So I will clarify this and kind of explain this while we're working through these. All right, so here we go. So first up is multiplying. So what I said, when you multiply, you are going to have to add the exponents. So when I look at letter A, I'm going to ignore the exponents at first. I'm going to multiply, and I'm going to say, what is 1.4 times 2.8? So go ahead and get that in your calculator. So I got 3.92. So 3.92, and then I have to deal with the exponents. Well, it tells me to add them. So I'm going to say 4 plus 7. So this is going to be times 10 to the 11th. The only thing I have to watch here when I put a final answer is, do I have a number between 1 and 10? If not, I'm going to have to fix it. But right now, 3.92 times 10 to the 11th is a good answer. All right, next one. I'm multiplying again. So again, 2.1 times 3.7 gives me 7.77. And then I've got to deal with my exponents. So times, whenever I put my wrist on the screen, it moves it. Times 10, and then I've got negative 2 and 5. So again, negative 2 plus 5 is 3. So this would be 7.77 times 10 to the third. All right, next one, we're dividing. So if you look back at your rules, what it says is now you've got to subtract the exponents. So now we're subtracting the exponents. So we still have to do the math. They're still asking us to divide those numbers. So I'm going to take 7.3 and I'm going to divide it by 2.9. that gives me, I'm going to round it. We haven't hit significant figures yet. You'll see that when we get there. So the answer there, I'm going to say 2.5. Well, then I've got to think about my exponents and subtracting them. Well, 9 is on top, 3 is on bottom. It's always top minus bottom. So 9 minus 3 is going to be times 10 to the 6th. And then our last one. This is the one that kind of trips a lot of people up here. So again, I still have to divide the numbers. 4.5 divided by 1.7 gives me 2.6. Okay, but then if you think about the exponents here, I've got to take top minus bottom. That is 7 minus a negative 2. So I know that you've learned this in math class, but 2 negatives make a positive. So I'm going to have to end up adding those, and I'm going to get an exponent of 9. So 2.6 times 10 to the 9th is the correct answer there. So there are 2 of the rules. There's multiplying, there's dividing. The third rule was adding and subtracting. Okay, so adding and subtracting can be a little bit difficult, but what it said in the rules was the exponents have to be the same. So that means, like on letter A, if I have 10 to the 4th and I have 10 to the 7th, I need to make them the same. They either have to both be 10 to the 4th or they both have to be 10 to the 7th. So think about the rules that I taught you to put numbers into scientific notation. So when you move it to the left, it makes it positive. When you move it to the right, it makes it negative. So I just kind of keep one in my head. I know if I look at that 3.7 and I'm at 10 to the 4th, if I move it one more to the left, that's 10 to the 5th, 10 to the 6th, 10 to the 7th, and I count. So really, I'm taking it out of scientific notation, correct scientific notation, so I can add. So really, I'm dealing with the number 0.0037 times 10 to the 7th. Well, now that it's the same as the exponent in that number, I can just add them. Then I don't do anything with the exponents. My exponent's going to be 10 to the 7th. But I need to make sure that those exponents are the same so I can add them. So really all I have to do is take 0.0037 and add 2.5. And I've got, the answer will be 2.5037 times 10 to the 7th. Again, I don't add, I don't subtract, not like multiplying and dividing. Once I get them to the same exponent, as long as I have a number between 1 and 10, I'm good to go. So on the next one, I've got 5.2 times 10 to the 22nd. And I've got 6.7 times 10 to the 18th. Again, in my brain, I kind of have to do the same thing every time or else I get it switched in my head. So I would be looking at the 18th there and say, okay, well, that would be 6.7. And if I move it one to the left, that's going to be 19, 20, 21, 22. Now it's going to be the same as that one. So my number is really 0.00067 times 10 to the 22. And now I can add them. So it's going to be 5.2 plus 0.00067. So you're going to end up getting 5.20067 times 10 to the 22nd. And those are the 2 answers. So if you want to pause me and try to do C and D, because subtracting is the same, you're going to do the same process. You just have to be able to then subtract the numbers instead of adding them. So if you want to pause me and try to do these on your own, that's great. If not, you can just kind of follow along. So on this next one, I see that I have an exponent of 10 to the 9 and 10 to the 7th. So I would take the lower one and say, okay, I've got 3.4. And again, my stylus is not working, which is why, let me erase that. I'm going to splurge and buy myself a new stylus very soon. Okay, so 3.4. And I'm at 10 to the 7th, and I need to go 10 to the 9th. So I'm going to say that would be 8, and that would be 9. So it would be 0.034 times 10 to the 9th. So again, I'm no longer going to use that number. So I'm going to say 4.4 minus 0.034 is going to be my answer. So it's going to be 4.366 times 10 to the 9th would be my answer on that one. And then the last one is the one where when you see negatives in the exponents, your brain is going to get twisted a little bit. Even I do this sometimes. So now that they're both negative, one's -4 and one's -6, you can't think moving it to the left makes it positive. In this case, I think moving it to the right is going to make it more negative. So I would look at the 1.2 and say, okay, well, it's -4. I need to make it more negative. That means I need to move it to the right. That would be -5. That would be -6. So I'm making it more negative there. So this would actually be 120 times 10 to the -6. So if you just kind of keep this in your head before I end, if you move to the left, you're making it positive. If you move it to the right, you're making it negative, because that can get twisted in your head. So I've got 120 times 10 to the -6, so I don't need that number anymore. So I'm going to be taking 120 minus 4.5, because they're both -6. The problem here is this is the number I get, 115.5 times 10 to the -6. Looks like a good number, but what I told you in the beginning was you need to have a number between 1 and 10. So what I need to do, and I'm going to do this in a different color, is 115.5 is not a good number to deal with, because that's not a number between 1 and 10. So what I'm going to have to do is I'm going to have to fix this, and I need to move the decimal to where I have a number between 1 and 10, which I'm going to move it right there. I'm using blue. So I've got to move it 2 places to the left. And again, to the left is positive. So that's +2. But I already had an exponent of -6. So I need to think about that. So this number would be 1.155 times 10 to the -4. Because +2 and -6 make a -4. So my final answer is right there in blue, 1.155 times 10 to the -4. So what I want you to do is I want you to go and complete the concept review for section 1.1 and 1.2 and make sure you get that turned in before class next time. Thanks.